Hi, I'm Steph Chavez. Today we're going to talk about flex and rigid flex PCB design. So what is flex? Flex is basically a flexible substrate material. Rigid flex consists of a combination of rigid and flex in combination in one actual PCB design. So that way you have one section of the design that's flexible and another section that's rigid that makes a collaboration of a rigid flex design. The reason why you would implement or enable flex and rigid flex in the design is due to a limited space requirement within an enclosure that you may have multiple boards that need to fit in there, but there's no room or there's limited room to add board-to-board connectors or cables. Designing for physical and mechanical constraints within a specified design envelope with limited space. It enables the opportunity to eliminate board-to-board connectors or extra cables, and it allows for a cleaner transition from signals to go from one CCA to another. Therefore, it increases the potential for signal quality. Implementation of flex and rigid flex PCB design is similar to standard PCB design. You do need to collaborate with your mechanical engineer as well as your board fabricator early and throughout the process. Within a rigid flex PCB design, you can have multiple board stack-ups within the same layout as if it's just one design, instead of the legacy approach of having multiple boards with multiple outlines that you then have to piecemeal together. When you're designing a rigid flex PCB design in one layout, you have the opportunity to have multiple board stack-ups, meaning that you'll have one stack-up that is in the rigid area, another stack-up in the flex area, and then another stack-up potentially in a second or third rigid area within the overall design. Yet it's treated as if it's one design. It just contains a rigid section and a flex section, or it contains multiple rigid sections and multiple flex sections with their respective constraints for their specific regions within the design itself. This enables to meet the specific form, fit, or function for mechanical functionality of the final product. The value that you would get from flex and rigid flex design has a high potential for return on investment. It enables you an opportunity to design a product that may not be otherwise designed if you don't utilize flex or rigid flex in the design itself. Ability to accommodate tightly formed factors within an electronic system. The potential to increase signal quality due to the elimination of board-to-board connectors or external cables. Offers a solution for a mechanical system that may require physical or mechanical movement or flexibility. A rigid flex PCB design was once thought of as too complex to design, or too costly, or too difficult to manufacture. But today, it's just as common and just as reliable as a standard rigid PCB design. Rigid flex and flex designs are typically utilized in products commonly seen in aerospace, automotive, medical, and military applications. Thanks for tuning in. I hope you now have a better understanding of the value of flex and rigid flex design, especially when you're designing a compact system like this, that the only way to achieve success is to enable flex or rigid flex in your design.